Good morning, good afternoon, or good evening, depending on where you're joining us from today, and welcome to this CM Crossroads webcast series event, Subversion Best Practices, Merging and Merge Tracking. This webcast is brought to you by CM Crossroads and is sponsored by CollabNet. I'm Patrick Egan, publisher of CM Crossroads and the Agile Journal. Well, in a few moments, Bob Jenkins and Paul Burba are going to join us to discuss the industry's leading version control tool, Subversion. But first, let me take care of a few housekeeping details to kind of help you get around. First, I hope you enjoy our new interactive livecast platform. We've completely redesigned the way we'll deliver online events of all kinds. The first thing you'll notice is the event chat window that's right below this screen. This will let you post questions to the speakers as well as to other members of the audience. Also, if you want to pop out the chat window, you can use the pop-up button down at the bottom of the screen. This will let you undock it from your browser window so it won't get covered up by the slides. Also, if you want to follow along at home, use the Twitter or Facebook buttons you can see down at the bottom of the screen as well too. Let you tweet about what's going on and let everyone else know. If you ever want to get a closer look at any slide, just mouse over this window and you'll see a full screen icon pop up. It'll expand the screen to the full size of your window. Also, if you want to download a copy of today's slides, just use the Slides tab you can see over on the side of the screen there. Also, you'll find copies of any other files that are available for this presentation. Well, let me introduce our speaker today. Starting things off is Bob Jenkins, Director of Subversion Services for CollabNet. Well, if you're ready to go, Bob, the floor is yours.
Thanks. This is Bob Jenkins, and I, too, want to express my welcome to all of you that have taken time to spend with us today. I think you'll find this well worth your time if you're interested in subversion and this particular topic of merging and merge tracking. So before we go too far, let's briefly go over what we're going to be covering in today's presentation. This is intended to be a technical discussion, so we'll get to the meat of things very quickly. But I do need to do a little introduction to be sure we're all on the same page, which we'll do in a moment. Paul will then discuss some of the essentials that you need to know and understand about merging and merge tracking within Subversion. Since I'm sure almost everyone on this webinar has experience with Subversion, Paul will talk about some of the bumps in the road that have come with the addition of merge tracking in Release 1.5. He'll also discuss briefly what's been done since that initial release of the feature to improve and fix issues with it. Then he'll look at what you might expect with the next release, 1.7, and beyond that, with what issues remain to be addressed. Since this is a best practices webinar, I'll let Paul get a breather while I talk about some best practices around the merge process that can help you get the most out of it with the least amount of pain. We'll then work to wrap things up before proceeding to the Q&A session. I'm certain there are numerous pent-up questions, so we'll hopefully address some through the materials in the presentation, but we'll also try to handle as many as we can that you give us along the way. I don't think I've ever started one of our CollabNet Subversion webinars by declaring prerequisites, but in order for us to dive deep on this topic, we need to expect that the audience is already familiar with several things. Now, if you're not, you're welcome to stay on, but just to understand that we're not going to cover the basics, so you may get lost in the discussion. First, you fundamentally need to have experience merging within Subversion. This isn't something that will likely bring a lot of value to someone who does limited merging very infrequently. Second, you should understand what merging really means and how Subversion defines and implements it. The idea of getting a diff of two trees and applying it to a third isn't a universal definition of merge, but it is Subversion's approach. Third, you need to understand the basics of the merge tracking feature that was added in 1.5. You should understand what kind of data Subversion is tracking, how it uses that data in general, and where that data is stored. Finally, you should be ready to dive immediately into a technical discussion that assumes you know the previous items, and you can apply that knowledge to what Paul is going to share. I can promise you that no one knows more about this topic than Paul, and I can tell you that even our own Subversion committers gained a lot when Paul presented this information, and a bit more, to an internal audience recently. If you want to know about merging and merge tracking, you're in the right place. So let me get out of the way and turn this over to the expert. Paul, the audience is yours.
Okay, hey all. Thanks, Bob. And thanks, everybody, for attending. As Bob mentioned, we expect that you are already somewhat familiar with merging in general and merge tracking in particular. Now, that said, I do want to spend 5 minutes covering some of the essential concepts of merge tracking. If you are a regular user of merge tracking, much of this is probably familiar to you already, but I still want to do it for two reasons. First, it helps establish a common terminology. I found that answering users' questions about merge tracking, we spend a significant amount of time parsing what the other person is saying, and it often ends up that we are saying the same thing. Second, I don't want to assume too much. It's quite possible to use merge tracking and never consider some aspects of the feature. So I hope many of you will find something new in this quick primer. And one other quick note, as Bob mentioned, I recently gave a presentation internally on the same topic. It went almost 2 hours, and I was trying to be brief. So given the limits on today's presentation, I'm not going to be doing any really in-depth examples, but possibly we'll get into some in the Q&A. All right, so for the essentials. At its heart, merge tracking is a process Subversion uses to decide what revisions have been merged or are eligible for merging from a given source to a given target. You're probably familiar with the most visible part of this feature, the SVN merge info property, which is a version property. Pretty much everyone refers to this property simply as merge info. The value of merge info property is simply a repository absolute path representing a merge source, followed by a sorted list of revision ranges representing the changes merged from that source. In the example here on the slide, there's only one merge source, but there may be many, and each will be on its own line. Now, merge info is unique among reserved SVN properties in that it is inheritable and mergeable. I'll talk about inheritance more in a minute, but by mergeable, I mean that the existing merge info is not replaced by incoming additions or changes. It's just combined with those changes. Now, like any version property, merge info can be edited by the Subversion prop delete, prop set, or prop edit subcommands, though we generally discourage doing this unless you're absolutely sure of what you're doing. Merge info, a few other notes about it. It can also have an empty string value. We call this, cleverly enough, empty merge info. It isn't very common. It is typically present, so a path doesn't inherit merge info from its nearest parent. Again, we'll get into that and talk about inheritance in a moment. One last note, and I only mention this because a few people have been confused by it. The ranges in merge info are inclusive of the start range. This contrasts with the -R notation that we use in the Subversion command line, where the start range is exclusive. Okay, merge info inheritance. Understanding inheritance is absolutely necessary to understanding all but the simplest merge tracking cases. There are 3 simple concepts to understand regarding inheritance. 1, the simplest case of inheritance is when there is none. When a path has the SVN merge info property set on it, we say it has explicit merge info and it doesn't inherit anything. 2, if a path doesn't have explicit merge info, then it can inherit merge info from its nearest parent with explicit merge info if such a parent exists. The merge info a path inherits is identical to its nearest parent's merge info, except that the merge source paths are adjusted for the relative path difference between the parent and the child path. So it's just a very simple path-based addition to create the merge info that you inherit. 3, there is one type of explicit merge info that is never inherited, the aptly named non-inheritable merge info. The name is somewhat misleading because it's really the individual revisions that are not inheritable, not the entire merge info. And this example on the slide, let's assume this merge info exists on a repository path, branch 1. This merge info shows that revisions 976, 980, 981, and 1005 have been merged to branch 1 from Subversion trunk. The last revision, however, has a non-inheritable star marker. This means that any children of branch 1 won't inherit that particular revision. Another way to think of this is that revision 1005 has only been merged as far as branch 1. Now, there are many ways in which non-inheritable merge info can be created, but many users will never encounter it. If you haven't seen it, be happy. Your life is probably a lot easier. And if your life is that easy, you're probably not even at this presentation. 2 things I want to emphasize here about inheritance. The first, if a path has no explicit merge info and no parent of that path all the way up to the root of the repository has any explicit merge info, then the path has no merge info whatsoever. Second, a path can either have explicit or inherited merge info, but never both. If a path has explicit merge info, this merge info serves as a complete description of the path's merge history. A final note, Subversion has always supported mixed revision working copies. Some parts of your working copy might point to older or younger revisions than other parts. Be warned, merge info inheritance doesn't always occur across mixed revision boundaries. The takeaway here is that prior to doing a merge, be sure to update your working copy to a uniform revision unless you absolutely need the mixed revision setup. Merge will still work in a mixed revision setup, but the results might not be what you expect. This concept of direct versus indirect is just one that I thought of recently because of some questions folks were asking me. Merge info is copied and moved along with the path it is set on. This is no different than any other version property, just is if you have SVN end-of-line style on a file and you copy that file, it's on the destination too. So just because a path has merge info for a given merge source and revision doesn't necessarily mean that a merge was literally done from that source to that path. Now, there's no quick way to differentiate between the two, and it usually doesn't matter. I only mention this because it means that when you create a new branch, it might start with existing merge info. And also, merge info tends to build up over time. As you reintegrate feature branches back to their parent, you're going to get that history will just accumulate and accumulate. There's nothing wrong with this. It's just something to be aware of when you're using merge tracking. Implicit merge info. Remember when I said if you don't have explicit or inherited merge info, you might have no merge info at all? This is sort of the exception. Understanding implicit merge info isn't required to use merge tracking. Arguably, it's an implementation detail, but it helps complete the understanding of how merge tracking works, so I'm going to spend just a quick minute on it. Now, regardless of whether a path has explicit or inherited merge info or neither, if it's in the repository, that is, if we've committed it, it always has implicit merge info. Now, implicit merge info is nothing new. It's just a way of viewing a path's history through the lens of merge tracking, specifically through the lens of merge info. Now, in this example we have here, we have a trunk line of development created in revision 420. Trunk at revision 713 was copied to create a new branch, B1, at revision 714. Now, if we check out that branch at revision 1011, we're going to assume work has continued on both trunk and branch here. The implicit merge info of B1 is a combination of its own history and that it shares in common with its ancestor trunk. If we view B1's history as merge info, explicit merge info, it would look like this. Trunk 402 through 713, which is simply B1's common history with trunk before it was copied, and then branches B1 714 through 1011, which is B1's own history after it was copied. Now, why this matters is because Subversion effectively adds a path's implicit merge info to any explicit or inherited merge info the path has. It then uses this total history when it makes decisions about what has been merged or is eligible to merge to that path. You can see implicit merge info in practice when you do a reverse merge of a change from a path's own history. Merge tracking doesn't allow you to reverse merge a change that has not been previously merged to the target or is not part of the target's history. So, like in this example, say on trunk, we committed a change in revision 1000. Then later we decide to remove this change. A common way to do this is to reverse merge revision 1000 from trunk to itself. Now, of course, the merge info trunk :1000 doesn't explicitly exist in trunk's explicit or inherited merge info, but it is part of trunk's implicit merge info, and therefore the merge is allowed. Now, if we're going to use merge tracking, we should know about the handful of cases where merge tracking doesn't kick in. There are a few cases where merge info is neither considered when deciding what to merge, nor is it reported to describe a completed merge. The first is when using the ignore ancestry option. These merges are simply the application of a raw diff, the same as that generated by the SVN diff subcommand. Second, if the merge source comes from a completely different repository than the target working copy, the merge will work, but merge tracking doesn't kick in any way. Third, if you are merging the difference between two unrelated URLs, for merge tracking to take place, the two URLs must share a common ancestor. Lastly, if you're using a 1.5 or 1.6 client against a 1.4 or older server, merge tracking doesn't work at all there. There is also one case where merge info is considered but not recorded. Recall on the last slide when I mentioned the example of reverse merging a revision from a path's own history. When you do this, no merge info is recorded because the current implementation has no way of recording negated merge info. It can only remove existing explicit merge info or set new explicit merge info in such a way as to override inherited merge info. You can see an example here. The merge works, no merge info is changed. The status, all you see is a change to the file. There's no property changes. Okay, time for my favorite subject, subtree merge info. And by favorite, I mean most hated. For something that has caused so many headaches, subtree merge info is pretty simple to define. It's explicit merge info found under the root of a branch. One of the most common causes of subtree merge info are subtree merges. By subtree merge, we simply mean where the merge target is below the root of the branch. Since merge tracking always records merge info on the target of the merge to describe the merge that just was done, this creates subtree merge info. Subtree merge info has been at the heart of many of merge tracking's growing pains. I'll talk more about this shortly. The only other point I want to add now is that the name subtree in no way implies a directory. Subtree merge info can be set on files as well. Now, along with subtree merges, the other common cause of subtree merge info is missing subtrees in the merge target. By missing subtrees, I mean simply that the working copy merge target is missing something. It is not a complete representation of a repository subtree at a uniform revision. So how can a subtree be missing? There are three common ways. One, the subtree is switched. It points to some other part of the repository, so the real subtree rooted at the switch path can't be affected by the merge because something else is in its place, something else from another part of the repository. Two, the working copy is shallow or sparse, if you prefer that term. They're equivalent. That is, you've checked out your working copy at some depth other than infinity, or you've modified the depth of your working copy with the update set depth option. Three, the subtree may not be present because the user simply isn't authorized to it. Now, there are also cases where the subtrees are present in the working copy, but are effectively treated as if they're missing. The most common of these is when performing a merge at operational depth other than infinity. That is, we're saying svn merge -- depth, empty, files, or immediates. In all of these cases, where the subtrees are present but treated as missing, or where they are literally missing, the merge will not be able to affect the missing subtrees. But assuming merge tracking has taken place, merge info will be recorded describing the merge on the root of the target, as it always is. This is a problem because these missing subtrees cannot inherit that merge info. To avoid this, merge tracking uses non-inheritable merge info and subtree merge info to isolate the missing subtrees so they don't inherit the root's new merge info that gets set by the merge. Unfortunately, time prevents us from looking at an example. We'll have some links at the end that have some very detailed walkthroughs that you can look at, and maybe we'll touch on this in the Q&A. So just remember, if your merge targets have missing subtrees, you're absolutely going to end up with subtree merge info if you don't already have it. Now, as Bob mentioned, we want to talk about some of the bumps in the road we've encountered since merge tracking was released in 1.5.0. Merge tracking was partially inspired by the svnmerge.py tool that some of you may have used. Unlike that tool, though, merge tracking supports merges that don't apply to entire branches, i.e. what we just talked about, subtree merges and merging to targets with missing subtrees. These differences are what create subtree merge info. And as I mentioned a few slides back, subtree merge info is at the heart of much of the confusion and most of the bugs related to merge tracking. But let's focus on the four big complaints that I've seen. First, prior to 1.5.5, working copy to working copy copies and moves created merge info on the destination even when none existed on the source. Technically, this was the correct approach, and we had contrived examples that could demonstrate that this was absolutely necessary, and please note the air quotes around necessary. But in practice, it simply isn't needed. Unfortunately, before we fix this in 1.5.5, many users experienced an explosion of subtree merge info. The second big complaint follows from the first. It goes something like this. I've been refactoring my Java code, and now I suddenly have hundreds of subtrees with merge info in my branch. That's bad enough. But now, whenever I merge to that branch, even if the merge affects only one file, every subtree with merge info is updated by the merge, and this is where the person usually starts cursing. So the signal of real changes gets lost in the noise of merge info changes. The third problem is performance. In some cases, as your number of subtrees with explicit merge info grew, merge performance declined dramatically. Not always, but in many cases, especially in 1.5.0. And lastly, in some cases, like we talked about, missing subtrees, when you merge to a target with missing subtrees, you could suddenly have new subtree merge info that wasn't part of the diff, and people would see this and become very confused. I still get questions on this, like, why is this happening? Why is this happening? All right. It's time to fess up. We simply didn't foresee the amount of subtree merge info some users would legitimately generate through their use cases. I have helped users with literally thousands of subtrees with merge info in a single branch. Now, part of the problem was that sparse checkouts and shallow operational depth were developed with merge tracking for 1.5 in parallel. So we didn't have a lot of time to consider how they would play together. And in some cases, they didn't play very well together. And part of the problem was simply that merge tracking was new. And unlike SVN merge.py, we were supporting subtree merges and subtree merge info, and it was hard to see how this would all pan out. Making all of this worse was the fact that addressing some of these problems wasn't always straightforward. We could easily stop recording merge info on subtrees unaffected by a merge, for example. That was very simple, quick change. The complexity came on subsequent merges. Because our algorithms had been relying on the fact that all the subtrees would be updated, and suddenly there were gaps in the collective subtree merge info, later merges would often try to remerge those gaps. Even though these merges were ultimately inoperative, this incurred such a serious performance penalty that penalty had to be addressed first, the algorithm had to be changed, and that was a little more complicated and took some time. Now, the good news here is, starting with 1.5.1, we have rolled out an almost continuous stream of performance improvements, bug fixes, enhancements related to merge tracking. The better news is that in the forthcoming release of 1.7, the worst offenders I mentioned on the last slide are going away. All right, this slide and the next are a summary of the major improvements we have made to merge tracking since its release in 1.5.0. This is not a comprehensive list. Really what this is my plea to get any of you who are not currently using a 1.6.9 client to use it. All of these fixes mentioned here are on the client side, so even if you're using an older server, they're going to benefit you. I won't go through each of these individually, but let's focus on a few. In the 1.5 series, as I mentioned earlier, in 1.5.5, copies and moves done within a working copy no longer produce merge info on the target if none existed on the source. So goodbye to subtree merge info caused by refactoring. In 1.6.0, the improvements continued. The two big ones to note here are 1.6.2 and 1.6.4, and these were performance when you're dealing with large numbers of subtree merge info. So if large numbers of subtree merge info sounds like your environment, you really, really, really want the latest client version. All right, it's time for my requisite wise guy slide. Please get a 1.6.9 client if you're not using it already, if it's at all possible to do. Because if you're having a problem with merge tracking and you ask on the Open Collabnet or Apache Users Forum, hey, I'm having this problem, the first question you're usually going to get is, are you using a 1.6.9 client? Or if not the first question, it will be the first recommendation to get. And as I mentioned on the previous slides, that list I just showed you is in no way comprehensive. So if you're running into some kind of obscure merge bug, it may have already been fixed by 1.6.9. All right, so what's new in 1.7? First, a disclaimer. I don't have a date for 1.7's release. The Subversion open source community will ultimately drive that date. I do feel safe in saying it will be sometime this year, but beyond that, it would just be a guess on my part. So anyway, when it is available, what is 1.7 going to bring us regarding merge tracking? The biggest improvement is that only subtrees affected by the merge will have their merge info updated. This will improve the signal-to-noise ratio between real changes and merge info updates when merging into branches with lots of subtree merge info. There are also a few other notable improvements. First, reintegrate mergers will better tolerate subtree merge info on the source of the reintegrate. If you have done a series of subtree merges or merges into shallow working copy, which still effectively sync your branch with its parent, you will now be able to reintegrate that branch to the parent. Previously, Subversion complained about unmerged ranges, and when you went to check those ranges or merge them, they're all inoperative. So the slightly naive interpretation of subtree merge info on the source during the reintegrate is improved. Second, record-only merges will now apply any SVN merge info property diffs from the merge source. What this means is that if you use record-only to record revisions that were themselves merges, the information is carried forward. Third, the SVN merge info subcommand will now have an option to take subtree merge info into consideration when reporting what has been merged or what has partially been merged to a given path. previously, SVN merge info only looked at the explicit or inherited merge info of the target itself, and even if you had done subtree merges under it or incomplete merges, it just didn't care. It gave you a rather naive answer. And lastly, new notifications were produced that highlight when merge info describing a merge is being reported. By describing a merge, I mean it's not a change that's part of the diff we're applying. It's merge tracking, does the merge, and then goes through its post-merge work where it says, all right, I need to record merge info to describe what I just did. Before this happened silently, and in cases of lots of subtree merge info, it's very confusing and led to the where did this merge info come from type of question and surprise. All right, let's take a very brief look at a 1.7 example. Let's say we have a branch with some subtree merge info. The branch has merge info on the root, and it has merge info on the SVN client interface file. So it has one bit of subtree merge info. This is a very simple case. We use our SVN merge info subcommand, and we see there are some revisions eligible to be merged. That's very typical stuff. We merge the first one. First, notice the new notification, which alerts us that merge info on the root of the branch is updated to describe the merge. You're always going to see that on the root of the branch. You'll also see it for any subtrees, none in this case, which are getting the merge info updated to reflect the merge. The bigger change is that only the root's merge info has been updated. The subtree with merge info was unaffected by this merge, so its merge info remains unchanged. Now, admittedly, this example isn't very dramatic, but imagine a case where the applied diff affects hundreds of paths, and there are scores or more of subtrees with merge info. In those cases, the new notifications and more conservative recording of merge info make for a clearer understanding of what the merge did, not only when you do the merge, but when you look back historically at the logs to say what changed here. It just keeps things cleaner, improves that signal-to-noise ratio we talked about. Now, there are still a few things that can be improved regarding merge tracking. Let's talk about a few of the major points. The first, and one of the biggest, cyclic or reflective merges need to work better when we're not using the reintegrate option to merge. By cyclic merge, I mean one where a branch is merged back to the parent from which it was originally copied. This can be direct, or it can have several branches, intermediate branches, but eventually it's cycling back to its common ancestor. So, for example, say we merge, the problem here is that the smallest unit that merge can deal with is a revision. And what a revision, the information a revision contains, it can have history from multiple places. For example, say we merge revision X from trunk to a branch. There are some conflicts. We resolve those conflicts and commit the change to the branch in revision Y. Now, revision Y contains parts of trunk's history in the form of revision X from where we merged in, and part of the branch's history in the form of the conflict resolution we did on the branch. If we then merge revision Y from branch back to trunk, we need to differentiate what is already part of trunk's history versus what is part of branch's history. If we don't, we can end up with needless conflicts, and that, when you're not using reintegrate, is frequently what happens today. Another problem is with renames and moves. Renames on either side of a merge prior to 1.6 didn't work well. You would get skips, or worse, you might delete really a newer path in your target. Things got a bit better in 1.6 because then a tree conflict was raised. So it was clear to the user that something was wrong. But ideally, merge should automatically follow renames on either side of the merge and do the right thing. Also, for those who use record-only to block revisions from being merged, like they record-only merge because they don't want this revision ever merged to this branch, the fact that you can't automatically differentiate a real merge versus a record-only merge can be a problem. I mean, you can look at the logs and look at the actual diffs and eventually figure this out. But it's not obvious immediately. We need a way to quickly identify blocked revisions versus revisions that were truly merged. Ideally, we need a way to block a revision from being merged anywhere, not just on a specific target we have used record-only on. And last, performance. It can always be better. No one is going to email me complaining, hey, merge is faster. It's just not going to happen. All right. handful of blogs, and one very lengthy document give more detail than we've had time to cover today. I'm going to warn you, some of these are really long, particularly the Merge Info Manifesto, as it's been called. But if you're looking for more information, it's a good place to start. If you understand these 4 documents, chances are you understand more than 99% of the people. All right, well, that's it for me. I appreciate you listening. I'm going to hand it off back to Bob now, and I look forward to the Q&A.
Thanks, Paul. That was definitely some very useful information, I think, to all of us. Now let me spend a little time to talk about what best practices that the people that are listening can utilize to make the most of merging and merge tracking with the least amount of pain, hopefully. And let's be honest, we all view merging as having some amount of pain no matter what the tool is that we may be using. So I'm going to look at my top 10 best practices, if you will, some of which obviously roll right off of the things that Paul has been sharing with us from that standpoint. So the first one is, let's re-emphasize a critical point that Paul has made, because we can't say it often enough. Almost all the improvements in merging and merge tracking are client-side. That means the newer the client you have, the better the experience. Today that means 1.6.9, as Paul's pointed out. But the general rule is to keep up to date. And remember, you can utilize a more recent client version with an older server, so you don't have to make the two be updated in lockstep. As long as you've got at least a 1.50 server, then you need to be using a 1.69 client. Second, Paul's made the point that the vast majority of the pain felt with merging and merge tracking comes from subtree merges. You can reduce this pain by reducing the situations in which such data is created. First, don't do subtree merges unless you really, really need to. Instead, look to merge from the top of the branch. If the only things you change are deeper in the tree, that's not an issue, so merge as high in the structure as possible whenever possible. Second, avoid doing shallow merges. That means avoid doing merges that you limit their depth. Related to that, then, is to avoid doing merges where subtrees are missing. Both of these situations arise through the use of sparse directories. Sparse directories may be great when you're coding, but try to use complete checkouts for merges. Third, your working copy should reflect a single snapshot of the repository or a single global revision. Again, mixed revisions and switch children may be very helpful during coding, but avoid them when it comes time to merge. Not only does it complicate the merge data, but frankly, it's hard for us to think through what's happening with such merges, and worse, for anyone to understand what happened historically. Fourth, there's a great temptation to try and fix issues by removing or modifying merge data, particularly subtree merge info. That is a dangerous place to go unless you really, really understand what you're doing, and be very, very sure that you do before committing such changes. Consulting others before proceeding is a good practice. Fifth, commit all the merge info changes that result from a merge. There can be temptations to not commit some subtree merge info, and sometimes we just don't realize that there's merge info above a point where we might want to do our commit. In general, commit from the top of your working copy, which should be the top of a branch, and include all the property changes within that particular commit. Sixth, do not have local changes in your working copy prior to doing the merge. You don't want to mix changes from two different tasks in a single commit, as then you can't identify what you did to resolve what, and you can't roll back a change or apply it elsewhere. The same is true here with the changes you choose to make prior to the merge. Commit those, and then make the changes because of the merge, and commit them. You also can't revert your merge if it is mixed with other changes. Seventh, have your working copy pointed to the latest revision on the target branch. Merging is fun enough once to not set yourself up to have to immediately experience it again by having to update your working copy before you can commit your merge results. Eighth, don't leave it to Subversion to document the merge, but instead put as much information as you have into your log message. There are lots of reasons for doing this. For one thing, the most common way that people will look at what happened and what occurred is through the log operation, and that doesn't inherently display the information stored in a property like SVN merge info. Also, the raw data that is stored doesn't always tell a clear story as to what you were doing and why. This is even more true when you're doing a subtree merge, or a merge that creates non-inheritable merge info, or as Paul just noted a minute ago, a record-only merge. Do yourself and your team a favor. Document your merge well. Ninth, validate your work by viewing what the merge operation did. Certainly you'll see the conflicts you have to resolve, but you should review all the changes made by the merge operation before proceeding. You shouldn't just assume everything happened the way you imagined it would. Finally, make sure what the merge and your conflict resolution has authored works. Every now and then I get a user that asks whether the merge operation performs an implicit commit. My answer is that we wouldn't assume that just because you saved a file or even exited from an editor meant that you had a valid revision to check in. So why would it be assumed with a merge? You need to validate the result builds and passes unit tests, the same as when you fix defects or implement new features. So, now a word from our sponsor. Version control is a critical part of a larger picture that we often refer to as an application lifecycle management, or ALM. Subversion does a great job with this facet for enterprises like yours, but your needs extend beyond it. CloudNet has always understood the broader need, and thus we offer CloudNet Teamforge to meet your needs for an ALM solution. We also know that there are very, very few organizations that aren't distributed, and most of us are frankly global. That adds another wrinkle in trying to answer the need for ALM, for which CloudNet Teamforge is uniquely prepared to address. We encourage you to leverage your Subversion use with a platinum platform optimized for it. See what it can offer you. So how do you summarize a technical presentation like this one? Well, first, we hope you learn some new vocabulary that will help you understand the breadth of what Subversion is trying to handle and will let you discuss issues with the right terms. Second, subtree merges are the largest culprit of issues, so whenever and wherever you can avoid them, please do so. Third, things haven't stood still since release of 1.5, so keep up with the client releases and be sure to be utilizing 1.69 today. Finally, we gave you a list of 10 merge best practices that you should become very familiar with, so you can utilize them and refer to that list as you need to do merges in the future. Well, I know you've gotten a lot out of the presentation today, but I'm certain you're also looking forward to getting some questions answered. But before we do that, let me point you to some places where you can get some information after this presentation is done. First, CloudNet supplies a lot of different resources around Subversion, including discussion forums and blogs, where you can get information from experts like Paul. We were the first commercial sponsors of Subversion, and we remain the deepest. Second, CloudNet provides certified binaries for Subversion, so take advantage of that by downloading them from our site. Third, we encourage you to look into how to go beyond version control with our CloudNet Teamforge platform, so come and visit our site to learn more about it. And finally, we'll be conducting a virtual conference on the 15th of May with the general theme of Agile ALM for Distributed Development. As you may know, CloudNet acquired a company called Danube recently, which has been focused on Agile development and consulting around it, particularly Scrum. So we have products and services that can be fine-tuned to focus on that process, as well as any other processes you may be utilizing. I'll have a session during that conference entitled Subversion for the Agile Enterprise, so I'd love to talk with you again there. At this point, though, let's go ahead and start answering some of your questions. So, Paul, I'll start feeding some of those. I'll take the ones that I think I can handle, and I'll ask you some of the ones that I'm going to pass off to you as the expert. So I'll start out with you first. When 1.7 comes out, do I need to be worried if some of my users are still using older clients to perform merges, Paul?
Yes and no. Yes, because the 1.7 users won't have to worry, because 1.7 client will expect subtrees to not always be updated. You know, the subtree is unaffected by the merge. The subtree isn't updated. It anticipates this. If you have a mixed situation where some of your mergers are using 1.7 and some are using 1.69 or earlier, those 1.69 users can suffer some real performance pain in some situations because their merge will look at all the subtree merge info and say, hey, it looks like there are gaps here when I take it in totality. I'm trying to merge revision 1,000 through 2,000. That's missing from some of these subtrees. It'll try to merge into those subtrees, and what you may encounter is they're all inoperative merges. But if you have a lot of subtrees with merge info, those gaps can become very fragmented, and you end up with what we call inoperative editor drives, where the merge is just churning, trying to merge all these gaps. They're all ultimately inoperative, but it takes a lot of time. And if you're one of these people with hundreds or thousands of subtrees with merge info, it can take a crippling amount of time. So when 1.7 comes out, anybody who's doing a merge, you want to use 1.7. If you don't have subtree merge info, you're probably going to be safe. But hey, there's no harm in using the new client if you can help it.
All right, great. I'll take the next one. Does Subversion really scale to large development teams? Are there any special considerations for large teams? The answer is absolutely. There are a lot of examples of very large teams using it, certainly large enterprises of thousands of users from that standpoint. It works very well, and certainly from a distributed standpoint as well. Special considerations for large teams, the main thing is to appropriately figure out your branching model, as it would be true with any tool that you might be utilizing from that, to make sure that you've got isolation where you need to have it, and that on the other end of things that you're sharing as often as you can handle it, because with large teams you're going to have people working on a lot of things that can have impact on other people on the team. So the longer you sit in isolation, the more surprise and the more impact that other people's changes may have. So it's really more about, applying the right principles of when do you branch and when do you merge, when you deal with some of the things from that standpoint that come into play. But, from Apache's own development to organizations that we have that have into the, 10,000 or more developers and large teams of hundreds of people, it certainly has proven itself to scale, and it certainly works well from that to even small companies as well and small teams. One for you, Paul. I have a lot of subtree and merge info. Can I just delete it all below the root of my branches and start over? It sounds like a few people have asked that for me before.
Yeah, and that's a question I've heard many times. Unfortunately, the answer isn't really straightforward. It depends. If the subtree merge info is the result of working copy, the working copy moves with a pre-155 client, yeah, get rid of that subtree merge info. You should be perfectly safe. But if the subtree merge info is the result of subtree merges or merges into a target with missing subtrees, you could very well be removing merge info that is describing what hasn't been merged to those subtrees. So if you ever want changes that do affect those subtrees, you're not going to be able to get them unless you use an ignore ancestry merge. And to add, it's not going to be very obvious that stuff is missing. So I would say if there's one rule of thumb, it's this. If you only ever merge to the root of your branches and your working copy merge targets have no missing subtrees, then you can delete all the subtree merge info on those branches and probably be safe. One warning about that, though. Unless you delete all the subtree merge info across all your active branches, if some of those branches are reintegrated back into the common parent, you're going to be bringing back that subtree merge info, and it might get pushed back out to your other branches. So if you do go to clean it, you got to do it all at once, which usually requires checking out all your branches at once and making one big commit. So it really depends. It's a type of thing that I would go to users. I would go to the Open CollabNet forums and say, hey, this is what I'm doing. What do I have to be worried about? Because there's so many gotchas here that we have to be cautious with a blanket recommendation.
Great. We have a question that says, does the Subversion client provide any warnings where possible that the user is about to perform an operation that is contrary to the best practices recommended in this presentation? I'll start with that, and Paul, if you got anything to add to it, feel free. The general client doesn't particularly have a lot of warnings from that standpoint. It puts a lot of faith in people to do things, and the fact that best practices are just that, best practices, not requirements. That said, you will find that we have at CollabNet provided clients, desktop clients, for a couple of environments, the Eclipse environment and for the Visual Studio environment. And in both of those, tried to enhance the merge capabilities of Subversion with our own merge management type of application in there, in which we do establish some best practices and the ability for you to require that those be checked prior to moving forward. Now, they're not required to have to be passed. You still have the option of deciding that that's okay if I'm warned that I have switched children or I have work that I have not yet committed or these types of things, or I'm not at the latest revisions, that I want to proceed forward. You still could do that, or you can go ahead and act on the issues that are flagged or, abandon your merge process to go and address those from that standpoint. Not all of the things there that we put in there are a part of that, but some of the main ones are in that list, and I think that's probably, as I best know it anyway, the clients that do the most around best practices. Paul, do you know anything more in that area?
Yeah, only to say that you're right, that open source version generally does what you ask of it and assumes you know what you're doing. The only exception to that is when you use the reintegrate option and merge. There are a lot of safety checks there to prevent you from shooting yourself in the foot. But with a regular merge, no.
All right. Let's see. I've got, sometimes when I perform a merge, subtree merge info appears that isn't part of the diff I'm applying. Where is it coming from?
Yeah, that, as I had mentioned, that is typically happening because have missing subtrees, and merge is trying to create subtree merge info or merge info on the root using non-inheritable ranges in a way that those subtrees, if they become present, won't inherit that merge info and therefore won't look like they had those changes merged. So basically, one of the links I had and will post that talked about where did this merge info come from. That's a lengthy blog topic about just this question. So check that out, and I suspect it will answer your questions.
Great. I'll answer this one. It says, can certain branches be locked so as no merging can be done to it? This way it can be kept in sync with, let's say, the code base in production. The short answer is to say no, because locking as implemented in Subversion is at the file level as it stands today. On the other hand, what really happens in a lot of these cases, particularly as you look at branches that you want more stability to, is people will more enforce who can make, who can create things and therefore who can merge them. So if we look at what I typically call a stable trunk model, where we're pulling back, what we believe to be stable that we've actually been developing on another branch into that trunk, then what you do is basically set up write access permissions to a limited number of people to do that, so that if merging has to happen, they're the ones that should know about doing it, and other users can't shoot things in the foot or cause more issues from that standpoint. So it's more of a process control with the potential of using access permissions around write that may come into play to be able to do something along that line and try to prevent some of the problems that you might get where you can. Obviously, merging is usually because you have to stop being in isolation and share some changes. So you got to be cautious about the idea that you can somehow just not have to go there. Here's one brief question, but I think it's because I've been looking a little further, and it's got different aspects, I guess, as we look at now and moving forward. What is, and I always differ on what exact pronunciation, because there are different ones for this, and I'll go with like elision. What is elision, and how does it play today and in the future in Subversion? Paul?
Yeah, elision. I say elision, tomato thing. It's the process where when we do a merge, if a subtree has merge info on it, at the conclusion of the merge tracking logic says, all right, this subtree has merge info. Does any parent, if it didn't have merge info, would it inherit merge info from a parent? If the answer to that is yes, it says, okay, is the merge info I would inherit from my parent identical to the explicit merge info I have on myself? If it is, it removes that merge info from the child because it's identical, redundant, sorry. Now, the problem with elision is it's not as smart as it could be. There could be differences between a child and a parent, and those differences could be inoperative on the child, so it doesn't matter. Hopefully, if we can find the time at 1.7 or shortly thereafter, we're going to smarten elision up a bit so it takes those kind of differences into account and helps you keep the amount of subtree merge info you have down to a bare minimum.
Right.
Hopefully that answers that.
At least for now. I'll take a first pass at this, and I'm sure you'll probably have some other things you want to put into it. Why would you want to use a subtree merge? What is the business case, and is this unique to Subversion? First of all, I'll start out, it's not unique to Subversion. So, there are cases where people will want to merge at a point that is not the root of the branch. The issue around it is semi-unique to Subversion in the fact that if you understand Subversion from a big picture, Subversion looks at the repository as a whole. So when it looks at changes, it keeps that at what is the impact of this set of changes that were a part of a single commit. What was the impact on them of the whole of the repository? Thus, we have the idea of global revision numbers. Whereas when we look at it with respect to other tools that are out there, certainly MyPass, Chitria, ClearCase, CVS, those type of things, those tools dealt with it at the individual object level, the file themselves, and applied the revision numbers at that situation. So where we run into some issues about where this information is being placed, in those tools, the information is placed in regards to each one of the individual files. It's already down in the subtree, if you will, and everything is at a submerge subtree merge kind of thing, and that's the way they have to deal with all of it. Whereas we have this potential of somewhat of a mixed environment where we've got data way up in the directory structure all the way up to the trunk, and we've got some data that may fall all the way down to an individual file from that standpoint. So it's got some things that make it unique to Subversion as the issue is a little bit more unique because of the way that we deal with changes and revision numbers and what we're talking about when we're talking about revision numbers. But it is something that people want to do. They want to be able to merge at points other than the trunk or the root of a particular branch from that standpoint. A lot of times that's, though, just a misunderstanding. They could do it at a higher level, particularly if they understood that, we're, again, looking at just the changes that were made along a particular path and the revisions involved there. So even if we shoot higher in the structure, if those changes in the range that we're looking to merge only included modifications to those specific pieces, then that's all that's actually going to get merged, even though we executed the merge from the top of the particular branch from that standpoint. But there can be use cases where they want to, apply a piece. If they, for some reason, looked at wanting to merge not the whole of a revision, but they needed to apply just a part of it to a specific file set, to a particular part of a directory structure, but there was more to it that was covered in the whole of the revision, then they might want to try to merge at an individual file or a subtree somewhere along those lines. So there are different cases for that. Like I said, I think it's overused, and partly just because people, with the other tools, as we've already said, those other tools dealt with things at the artifact level down to the file level from that standpoint, and so it was not uncommon to do a merge at that level. So part of it is just learning how to best utilize Subversion and how does Subversion work, and really that there isn't as much requirement for those as they probably are implemented, but there are some use cases. You got anything that you'd like to add with that, Paul, or does that sound fairly accurate?
Yeah, pretty much. I mean, I do see one that people have very large branches, so they only want to check out a portion because they know all the changes are underneath that subtree. So while they're merging to what is effectively the root in their working copy, it's really a subtree of the branch. But I think you more or less covered it.
All right, I'm going to try to give you a use case here. So listen carefully, Paul. So I have Tortoise Subversion, or Tortoise SVN 1.67, Subversion 1.6.9. We have a branch that was created from a trunk, so we have a child branch. Both have ongoing work, so both are changing. And I try to do a merge of the branch to the trunk regularly. I discovered a few weeks ago that when I use a range of revisions and leave it blank, that it is not picking up files that I know have changed. Is the problem that we are keeping the branch and trunk open too long, or is it using the range of revisions each time confusing things?
Well, I would say, so they're merging the branch back to the parent trunk periodically? Is that their question?
That's their issue, yes.
Okay. Well, I guess it depends if they're using reintegrate or not. If this is a cyclic merge, if we have a trunk, branch was created from trunk, work continues on both trunk and branch. Now, if we want to merge branch back to trunk, our best practice is to keep branch in sync with trunk by merging periodically everything from trunk to branch that we can, and then using the reintegrate option to merge branch back to trunk. When you do this, if you want to keep branch alive, you need to record the fact that reintegrate merge took place on trunk. So you need to do a record-only merge from trunk to branch of the revision which you did to reintegrate, and then the branch can continue to exist and you can keep syncing it with trunk and reintegrate it later. Or you can just delete the branch and then recreate it immediately after doing the reintegrate. Now, it's not clear to me from this question if they're even using a reintegrate. If you're not using reintegrate and you simply have a trunk, copy a branch, and then try to merge branch back to trunk, this is the cyclic or reflective merge problem I talked about. And in all but some of the simplest cases, you're going to have trouble there. I would try to use the reintegrate approach to do this. This is hard because I probably need a few more details to understand exactly what they're doing, exactly what their problem is. But that would be my first response.
Oh, that's fair. We can only get as far as we know the information at the moment.
Yeah. Use reintegrate. That's what I would say.
From that standpoint. Here's an interesting one. We have been using Subversion for years at our company with many large repositories. We have never used merge tracking up to this point. What caveats are there with trying to start using on an old repository like this? So I'll take a shot a little bit, Paul, and let you think about it a little bit more, and then you'll come in and fix me from that standpoint. If you haven't been using it, and there's two possibilities of it. Obviously, based on what you've written here, my assumption is that you're not using the Python script that was available prior to that at 1.4 that kind of addressed some of the same kind of pains only at the path level, up at the trunk or the root of the branches from that standpoint. So assuming you didn't have it all before from that standpoint, there really aren't any huge caveats. I think the biggest thing to say is that you obviously first of all have to get to the binaries for that. You have to activate it, which is using the admin command with upgrade to get merge tracking turned on. And then the hugest thing we get another opportunity to mention it, Paul. That is start with 1.69 as your client, irregardless of where you end up upgrading yourself to with regards to the server. And hopefully you'll get the latest on that. That would be terrific. But if you get to any other version of it, make sure you're working with clients at 1.69. And you're going to start off with a much happier experience with merging and merge tracking than people that have started with 1.5 or other places along the line and have to absorb getting the fixes and the changes that Paul's talked about that have come since 1.5 to 1.69. So I think that's probably the key thing, and then just understanding what's going out there. Understand the specific use cases that are covered, like we mentioned the reintegrate. That's going to be something new to you that isn't there before. It's a very special case of dealing with bringing a child back to its parent. It's not for every time we do that, but in specific cases for that. So be educated about merging as implemented with 1.5 and beyond, and utilize 1.69 clients. Anything you'd add there?
Yeah, I was going to say, if you have not been using svnmerge.py and you're not going to be running the svnmerge property through any of the conversion tools, let's just say you've been using vanilla Subversion, existing branches that you have will not have any, when you convert and start using merge tracking, will not have any merge info or any representation of the merges that have already been done to them. So let's say you have a long existing trunk and a long existing release branch off that trunk. If you've been periodically, like over the years, merging revisions, cherry-picking revisions from trunk to your release branch, when you suddenly start using merge tracking, you should be okay because you're still probably just going to be picking individual revisions. You may want to use record only to go back and retroactively record that history of what you've already merged, but you don't have to. The bigger problem is if you have an existing feature branch that you were eventually going to bring back to trunk using the old school 2-URL merge approach. If you do this switch over in the middle of that feature branch, if you try to use merge to just say, hey, merge all the revisions to it, use merge tracking, merge everything that hasn't been merged, it'll think nothing has been merged since the branch point. So you'd have to exercise a little caution there. That's really the only big problem I could think of. But again, there you can use record only to record what you've done thus far, because I'm assuming you have some record of it, probably in the logs. You could use record only to report what you've done thus far, and then you can just use the approach where you say svn merge trunk to my feature branch, and it'll just merge what has been merged so far.
Great. I appreciate everybody's time, and I hope you all found it useful, and look to talk to you again next time.
Thanks, Bob. And thanks, everybody, for attending.